Hi everybody. So here's the question from the homework for today. This is January 6th, or January 7th, I mean Thursday. For calculus, the homework problem that I had given you to take a look at, that we did about half of it and then just kind of ran out of time. So let me go ahead and finish it for you so you can at least see how it works. It starts off like this. We're looking for the limit as x goes to infinity of 1 plus 1 over 2x to the 3x power. Okay? And if you just plug in, so to speak, infinity, what you end up with here is an indeterminate form of 1, because this term becomes 0, so 1 plus 0 is 1, to the infinity power. Okay, now this isn't actually indeterminate because we can't just apply L'Hopital's rule at this point. Remember, we have to get a 0 over 0 or infinity over infinity to do L'Hopital's rule. So what we're going to do is do some algebra magic here to make that happen. The trick that we saw in class a couple of times is to do this. Let's let L be this function. Okay? If we take the log of both sides of this equation, we end up with this right here. Remember, the 3x can come down in front. Okay? And if we go ahead and just look at the limit when x goes to infinity, now we have an infinity times, now what's log of 1? 0. So what we end up here now is with an infinity times 0. So we're getting closer. Now all we need to do is turn one of these factors into a denominator so that we can get the indeterminate form we need. I don't want to put that in the denominator because then I'll get 1 over the log, and that's going to make stuff really nasty. So I'm going to try it with a 3x. So what I'll do then is this: log of 1 plus 1 over 2x over 1 over 3x, like that. Okay? Cool. Now we have an indeterminate form of 0 over 0. Because if we plug in a very large number, this goes to 0, the whole thing goes to 1, log of 1 is 0. This goes to a very large number, so the whole fraction goes to 0. Excellent. Now we are where we need to be. So now we can use L'Hopital's rule. Okay, put a little thingy on the O. We'll use L'Hopital's rule, and let's take the derivative of the top, 1 over stuff times derivative of the stuff. And this is where the wheels kind of fell off today in class. If we take a look at that, and I'll tell you what, let me just do it over here off to the side. 1 plus 1 over 2x. Okay? The derivative of this is, well, let me write it like this first, because then it'll make it easier. There. Now we can do the derivative. Derivative of 1 is 0. Derivative of this term is negative 1 times 2x to the negative 2 times the derivative of the inside stuff. Right? Outside function, inside function. So if I simplify that just a bit, I get negative 2 over 2x quantity squared. And I can simplify this just a little bit more, and I get negative 2 over 4x squared, which is equal to negative 1 over 2x squared. Okay, so what this derivative ends up being then is derivative of the log is 1 over the stuff times the derivative of the stuff, which we just found out is negative 1 over 2x squared. Great. That's the derivative of the top. Now, as Matteo so rightly said, we got to do the derivative of the bottom too. Okay? That's the derivative of this fraction. Let me write that over here in blue. The fraction is also can be written as 3x to the negative 1. Its derivative is negative 1, 3x to the negative 2 times 3. Like that. Outside function, inside function. That's negative 3 over 3x quantity squared which is negative 3 over 9x squared, which is negative 1 over 3x squared. That is my derivative on the bottom. Negative 1 over 3x squared. All right? Good. Now what I want to do is I want to go ahead and take that. I want to copy it to the next page because we've got to do a little bit of algebra to make it work. Okay, so I've copied it to the next page. So now I can start working a little algebra magic. Okay? Here's what I'm going to try and do. Let's see. Let's go ahead and multiply these together first. Negative 1 over 2x squared times 1 plus 1 over 2x, all over negative 1 over 3x squared. Okay? The negatives will cancel. Let's bring this denominator up here to the very top and slide that down below. A little algebraic thing that I can do. 3x squared over 2x squared times 1 plus 1 over 2x. Okay? Now, remember that rule? If that confused you, let me show it to you with a little simpler case. A over B over C over D is equal to A over B times D over C, which is equal to AD over BC. You see how the D ended up here on top with the A and the B ended up down here with the C? So that's basically what I did here to make that work. Okay. Okay, so I got rid of that. And now I can simplify a little bit more. Oops. That's not right. Let me get rid of that. There. Okay. The x squareds will cancel. So all I'm left with is a 3 over 2 times 1 plus 1 over 2x. Okay, we did the L'Hopital's rule. If we plug in the limit now, so let's go ahead and do the limit as x goes to infinity of 3 over 2, 1 plus 1 over 2x. As x goes to infinity, this fraction gets very small, right? So that goes to 0. 1 plus 0 is 1. 2 times 1 is 1, or 2. And so the limit ends up being 3/2. Okay, now if you remember, when we first started, we said let's let L be this function. Okay? And then we took the log of both sides. So what we really found is not L, we found the log of L, the limit of the log of L. This is the limit of the log of L. What we need to do now is go ahead and bring that back up so we can find L. If the log of L limits to 3/2, okay, log of L is equal to 3/2 when the limit's done, then L should be e to the 3/2. And there's your limit, e to the 3/2. And if you graph this function on your calculator and then take a look at the function as x gets large, like 100 or 1,000 or 1,000,000 or something, you'll see this goes right to whatever number e to the 3/2 is if you compute it. That's how you do it. We'll see you tomorrow.